15.1 Mean and Absolute Value. The mean, or the average, is the sum of the data divided by the number of items. The mean absolute deviation, you subtract the mean from each data value and average the differences. And the measure of variability is how spread out the data is. So, example 1, the data represents the height in feet of various buildings. Find the mean absolute deviation of each set. So example 1, the data represents the height and feet of various buildings. Find the mean absolute deviation for each data set. So the first thing I need to do is calculate the mean to the nearest whole number. So I would add 60 plus 58 plus 54 plus 56 plus 63 plus 65 plus 62 plus 59 plus 56 plus 58, and that sum divided by the number of data items I have, which is 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. I have 591 divided by 10 is equal to 59.1. But to the nearest whole number, that would be 59. So now I'm going to subtract the mean of the data. So I'm going to subtract 59, subtract 59. From each data point. Now I've got to find the distance from the mean. So 60 minus 59 is 1. 58 minus 59 is negative 1. 54 minus 59 is negative 5. 56 minus 59, negative 3. 63 minus 59 is 4. 65 minus 59 is 6. 62 minus 59 is 3. 59 minus 59 is 0. 56 minus 59 is negative 3, and 58 minus 59 is negative 1. So once I finish that, I have to calculate the averages, but it is mean absolute deviation. So I will not add any negative numbers. I will add the absolute value. So all my numbers must be positive. So then I need to find the mean of all of those differences. So I would add 1 plus 1 plus 5 plus 3 plus 4 plus 6 plus 3 plus 0 plus 3 plus 1 and divide by 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 for a total of 27 divided by 10, or 2.7. Rounded to the nearest whole number, the mean absolute deviation is 3. Okay, I'm going to give you a chance to try on the back side, and then we will check it. Okay, when I found the mean of my data to the nearest whole number was 50, I subtracted 50 from each data value. I found their absolute value, and then I found their average. It came out to 3.8 repeating, and it wanted it to the nearest whole number, so I should have put 4 instead of 3.9. Okay, the next one, it says, compare the math. Which one is greater? Are the heights very spread out? So, from the mean absolute deviation of our first example was 3, and the mean absolute deviation from our second example as 4. So A or B has the greater mean absolute deviation. And because the mean absolute deviations are quite a low number, no, the heights are not very spread out. Okay, amount of baristas A's large coffee in ounces and barista B's in ounces. We need to find the mean absolute deviation of those and which one shows less variability, meaning which one's absolute deviation is smaller. And then we'll check it. So this down here gets a little bit small, so I was running out of space. I hope you can follow. I found the average. I added the sum. I got 199 divided by 10 was 19.9 and rounded it to the nearest whole number was 20. I subtracted 20 from each of the data points and I have my differences. And then I added those up and got 6.3 divided by 10 is 0.63. And then I followed the same process on the bottom. I found the average of the data, which was 200.1 for a sum divided by 10 is 20.1 and rounded again to 20. Subtracted 20 from each data point. I got 2.1 divided by 10 is 0.21. And I compared these. 0.21 or 21 hundredths is smaller than 0.63 or 63 hundredths. So barista B has less variability.